This is the final part in the current video on designing a circuit in Fritzing. This is based on a Raspberry Pi hat board for a light-up model railway house project. It doesn't actually meet the full specification of a Raspberry Pi hat, but it's close enough for a simple design and makes it easier to create in Fritzing. In my earlier videos, I've shown how to create the circuit design using a schematic view and create a prototype using a breadboard. I've then taken that and created a printed circuit board in Fritzing using the PCB view. This has been manufactured, and in this video I'll go through the steps to solder on the components and install the software on a Raspberry Pi. It's taken just under 2 weeks to get the board since uploading the Gerber files to the manufacturer. Here you can see the top and bottom of the PCB before installing the components to it. You can see the component positions which are marked white in the silk screen and see the faint lines showing where the tracks run. As I mentioned in the previous video, there is a ground plane across the board covering all the empty space. This has consumed the ground tracks we had included in the design, so we didn't need to actually include those. I've got all the components required, which will be soldered to the board. I'll also be showing how to solder wires and add female headers onto the external components, such as the LEDs and NeoPixel. This will involve crimping the headers onto the end of the wire. And here's the printed circuit board come back from fabrication. So I ordered it in red. It's nice to have different colours, but the main reason being that this would match the colour of the walls inside the house, so it's going to be less obvious if you're looking through the window, because I've got a clear window on the model of the house. As you can see, the white writing shows where all the components are going to go, which I've labelled up. Then it's a case of connect the components together. So I've got the connector, I've got the 4 MOSFETs, got various resistors, for the different parts, and the resistors are all labelled, which is one of the things I did. And the 2 connectors, and then lastly is these connectors, which are going to be to push the LEDs and the NeoPixel onto. I'm going to use this dual row header, and I'm just going to break this to size. That'll solder on there. This is the same as you might use for soldering the GPIO pins onto a Raspberry Pi, particularly the Raspberry Pi Zeros that don't come with these pre-soldered on. I'm just going to break it to size, and then the idea is you have female connectors that will just push on this and connect to those. Of course, I also need the LEDs that are going to be used, but I'll solder those up separately. I'm just going to concentrate on the PCB first of all. So I've got my soldering iron, some wire cutters, these side cutters that I use to cut off the legs of the components once they're done. So I'm going to start when soldering using the smallest components which fit closest to the board. That way it makes it easier, because if you try to solder the big components on first, then you'd have a job holding the smaller components in place. So I'll just start with the resistors. Start with the 680 ohm ones first in the bottom corner. Bend the legs. Now, it doesn't matter which way around you put them, prefer it that way. Some lead-free solder. Bring the soldering iron in contact with both the pad and the pin. Hold it on, remove the solder before you remove the soldering iron. And then clean the tip of the soldering iron. I'm using some brass wool here. That's the first resistor soldered on, so just cut off the legs, hold on to them when you do it so that they don't go flying everywhere, and that way you can put them straight in the bin. Right, so I'm going to carry on soldering the rest of the resistors. So now I'm going to put on the FETs. You can see that the shape of the case has got a curved side and a flat side, which corresponds with the curved side and flat side of that. And then the 3 pins, you can either pre-bend these, or if you just line them up, you should be able to get them in and push them in like that. And just the same as before, solder each pin and then cut them off. So when you're doing the resistors, there's not much time limit. You can get them quite hot by leaving the soldering iron on. Once you start to get onto semiconductors, then I like to try and get them done as quickly as possible. You don't want to overheat the component. Cut off the legs. Then I'll carry on and do the rest of these. So for the headers, I just need 6 of these. So there we are, we've got the 6, and just the short pins go down underneath and the long pins will be for us to drop the connectors onto. Now at this point I'm going to find some Lego comes in useful. So I'm wanting to hold this flat and keep all those pins up. So usually something underneath it, providing a bit of support on the corners, should hold it so that I can solder onto there. I'm just going to solder the two corners first. If I solder two diagonal corners, allows me to make sure that that is flush, and that's fit quite nicely. If you wait until you've done them all, then it's a real job to try and correct that afterwards. That's all those pins soldered on, and there's no need to cut anything off there, they're just the right length. So now we've just got these two connectors and then the Raspberry Pi connector to go on the bottom. So use the smallest first. Again, just put a piece of Lego underneath, hold it in place, and make sure they're flush. Now the larger connector. Now, you don't need to cut off any of the lead on these, but as I took it off, a bit of the solder got dragged away with the soldering iron, so I can just cut that off. Make that look a bit neater. So there we go, and then the final thing is to put this connector on. And remember, this is going to go on the Raspberry Pi, and so this needs to be on the bottom side. It's the only component that does. And this is something you want to try and keep nice and flush, so let's see what we can do. And again, just solder two diagonal corners for now. Gives us an opportunity to check that that's nice and flush. Yeah, that's perfect. And then just go through and solder the rest. And then that's the soldering all finished. I will solder the LEDs up separately, but now take it as an opportunity to check all the soldering. You might want to use a magnifying glass to look at some of these, and looking for that you've got a good circular fill completely around the component and covering the pad, and there's no obvious gaps in that. But you're also looking, particularly on these pins, to make sure that none of the solder has gone from one to the other and you've got no bridges between the two. That could actually do some damage to the Raspberry Pi potentially if you've got any of those. So do double check that before you actually connect this to the Raspberry Pi. And here you can see it with the PCB mounted on top of a Raspberry Pi. I'm going to solder these two wires, I've already cut them to length, to this red LED that will be used in the fireplace. The black will be going to the shorter wire and the brown to that. So I'm going to start by just stripping off a bit of the insulation at the end. You can see that this is a stranded wire. And what I need to do is to hold this in place there as I solder it. Helping hands type setup, third hand it's sometimes known as, or various things. So these are flexible pipes with crocodile clips at the end, and the idea is just because you can move these to hold your components in the right position. So this is the brown wire, so this is going to go to the positive, the long lead. And I'm just going to try and hold it there. It just seems to have lined up perfectly. That doesn't normally happen. Normally you spend a lot of time twisting, adjusting and trying to get them in the right position. But once you've got them in that position, this should make soldering them a lot easier. What you wanted to do is hold the soldering iron to both wires and then run the solder along them. I'll try and do this from the back so that you can see, and run the solder along to make a joint across. Oops. Let's just knock that slightly. If you can get it to hold it like this, and this can, I usually find this has got the best experience, is it? There we go. And that is a nice joint along there. I can just trim a little bit of that wire off, although I don't need to. Now, I did say that I was going to use some heat shrink sleeving. This is the one I'm going to use. This is 1.5mm diameter, and the idea of this is it's going to go over the joint, and then when you heat it up it shrinks to fit, and then adds insulation, because obviously if these two touch then you'd short out your LED. If you were doing a long run of wire, or if you've already got a connector on the other end of the wire, then this is going to be impossible to add afterwards. So usually try and remember to do this beforehand, but if you've just got a short length of wire then you don't need to do that. I'll cut off my second piece as well while I'm at it, so I get the two about the same length. So then I'm just going to slide this on. And there we go. Now I'm going to repeat the same for the second time to put the insulation, the sleeving on first. So it doesn't matter in this case, but it's a good habit to get into to make sure that if you're going to use sleeving, you put it on, because if not, you'll end up doing it. And I've inevitably done it quite a few times where I've not been able to add the sleeving afterwards. I've had to undo my solder joint and then redo it. So just apply that, and see, that one's worked. And now I can remove that, and that's got a nice joint there. I just slide the sleeve in over the top. There's a little bit of wire just protruding there, I'll just trim that off. So I've gone for the smallest sleeving that I could on here, which is actually really fits really nicely. But if you're not so confident on your soldering, you might want to use a slightly wider diameter sleeving so that it slides on easier. So I'm now going to shrink this sleeving. So you can use like a DIY heat gun or something like that. I've even seen people use candles, but I'm not a fan of that myself. I've actually got this workstation. It's very noisy when I put it on, but this is just going to apply heat through this nozzle, and you'll see the insulation shrinking as I do so. And there we go. This stuff is actually just really good. The shrink sleeving just shrinks really nicely. And then I just twist the wires together, and then it's time to add the crimp at the other end. So at the other end, I'm going to go onto these headers on the PCB, and I'm going to do that using these connectors. You might have come across these before. These, you normally get these pre-wired with a male pin or a female pin that you can push into a breadboard, so the jumper leads that we often use. In this, often they're single when you get them, but you can get multiple connectors. And for this one, I'm going to use a dual connector, and then it'll just pop onto the 2 pins like that. And to use these, you need an appropriate crimping tool. The one I have here is model SN2, and this one's got the smaller connectors. You need to make sure you buy the one with the right connectors. It's got 4 different sizes. This will go in the smallest size. I just need 2 of these. These are the female connectors with the hole in. I'll just break off. And you have to push it into whichever one fits best. In this case, it'll be the end one, because these are the smallest connectors it's designed to hold. Sometimes you might have to just squeeze a couple of the 2 end lugs together gently. That one's gone in there. And then, first of all, you just pull it until it grasps the connector, but not actually put any much pressure on. It's just starting to bow slightly. Then take the ends. They need to have the wire stripped on them, off them, but it's only a small part of the insulation. They don't need to be as far as the ones before. And this then just pushes into that connector. And this is the thickest wire you'd be able to put into this. So remember, this is the 0.32mm or 22 AWG that I'm using here. And then squeeze it. And it's basically gripped that together and made a good joint there. And then repeat the same for the other connector. Push the wire in. Yeah, that's made a good connection as well. And then it's just a case of threading these inside, and there's a little lug on the back, so you need to make sure they're going the right way around, which lines up with this hole, and that's
better. There we go.
That's nice and secure, and then that will just push on here. So this is the fire, and the negative, which is the black to the right hand side, and then that just pushes on there and makes the connection, and it can be easily removed and then put back on. Okay, so I'm going to carry on wiring the rest of the LEDs up. I'm going to solder up the RGB addressable LED. This is essentially the same as a NeoPixel, but using through-hole technology. So you could put this onto a printed circuit board. But in this case, just like the LEDs, I'm wanting this to be separate. So it's a case of soldering onto these wires. It's going to be using the thin white wire again. So all four, I'll only be using 3 of them. The plus volt, ground and data in. But I'll be using just the one colour so that they can be hidden better. To make sure that we know which one's which when it comes to the end, I've actually done some little labels on here. These could be temporary or permanent, see how much they're in the way, but so that we can label them up as we do them and not have to try and remember what goes where. So just go through here. If you hold it, there's a flat part here. There's 2 long pins and 2 short pins. The 2 short pins are starting from left to right with the 2 short pins on the left. The short pins are data in and VDD, or the supply voltage, 5 volts. And then the longer pins are ground and then data out. So we don't need the data out. We'll be using those other 3. Might leave the data out just bare if I decide to change something else onto it at a later date. So I'm going to use my thing. I'll just sort out my wires first. So I want to get 4 wires about the same length. Reasonably generous. This can go to the snowman, which has been 3D printed, so that we can have a colour changing snowman. Use this again. I'm going to start with the top short wire. Which will be the data in wire. And I've got some heat shrink. It's going to be very important to make sure the 4 wires don't touch. It could be added on afterwards. This wire's not that long. Trim off the excess. Yep, so now the second shorter wire. Put the others slightly out of the way. Which is for the VDD. I'm just going to put this label on here before we go into that. I'm going to slide this on afterwards because on the last one it slipped down that much anyway. Important now, thread this on before I put the sticker on, because obviously I won't be able to do it after that's on. And this one is labelled as VDD, so it's essentially our 5-volt power supply, so I'm just going to put a sticker on so it's 5 volts. And finally the ground, which will be the next one, which is one of the larger wires. It has just joined the two together, so I just prise those apart, make sure there is no connection. In fact, I'll just snip that way. So it is a bit more fiddly, in fact, a lot more fiddly doing this than it is just doing normal LEDs, because you've got extra wires. Although we don't need one on this last one, I'm going to put one on that as well, just to cover that up completely. And then I'm going to heat those up and get them to shrink. There we are. So just important to make sure that none of those wires can touch each other. Label the last wire, although obviously if the others are wire labelled, it's obvious which one this one is. Then I can crimp the connectors onto the other end. This out of the way. push the wire into the connector. Then crimp it shut. Repeat that for the other connectors. So now that these are crimped, it can go onto a 4-way connector, and the easiest way is to take one of the printed circuit boards or the print out and just remind me, so that because power is the top two and then the bottom one is the data. So if I do them plus 5 volts in that one. Then the ground in the one next to it. And then the data in goes in the bottom one, on the bottom left. Just didn't quite have that far enough in, so there's just a tiny bit of the cable hold that's not being crushed properly. Just use a bit of pliers and pop that into there. There we go. So that's all wired up, ready to go onto the soldered PCB. Finally, it's time to wire it all up and see if it works. And at this point, just need to make sure that none of these wires are touching the LEDs, and just should be staggered. It goes red, green, red, green. I think when I did the one before, I didn't have quite as much bare wire, so it was easier to keep them separate. So probably, if I solder up some more of these, which I probably will, I will put heat shrink sleeving on. Got some transparent sleeving that should probably work quite well. The roof goes on. And then 3D printed snowman. Again, all the files to download, available to download. And we put that in front. So I'm just going to add some the smoke fluid. Just use this needle to that should be enough, and it needs a tiny amount. Turn on my external power supply. The final things, finishing touches to add a more festive look, is some snow. So I'm going to use this. This is snow in a can. Just add water. It's a polymer based snow. It even includes its own little shawl for shoveling the snow. So we pour that into the can. And just add water. A small jug here. So there's a small amount at a time. As the water goes in, it expands. What I'm trying to get is a good amount of expansion, but I don't want any water to be left that could get on any of the electronics. Apply that to the roof and liberally sprinkle it around, and use that to hide this wire. And then of course the finishing touch is to add a Christmas tree as well, and that's already got a sprinkling of snow on it. You could of course put these LEDs around the Christmas tree if you preferred to have it like Christmas tree lights. I didn't do that because that means running the wires outside the building and then trying to thread them around the tree, but that's certainly achievable. And there we go, the finished house. Details of how to set up NeoPixels and download the software are included on my website. I'll include a link to this in the description. I've already set up the NeoPixels and downloaded the software, and I'll show you the next steps. Change directory to the Christmas house folder where I've saved it, and then sudo pgzero to use, this is a pgzero application and it's called house.py. Sudo is required to run it as root because of access to the NeoPixel code needs to run as root. There are a few warning messages when you launch it. This is about the sound, which is due to the fact that we've disabled the sound on the Raspberry Pi because it conflicts with the NeoPixel code. And this is the interface, and it's really just a picture of the house written in pgzero, and it allows you to click on certain elements to turn the things on and off. As you can see, it's already turned everything on. The NeoPixel is changing colour. The lights are flashing in sequence, and the lamp for the white light for inside the building is on. The one thing that isn't on is the smoke machine and the red LED for the fire. This is intentional because in use you would need to make sure that you put in the fluid for the smoke machine first. So it's one thing that you have to manually do is to click on the elements to turn them on. In this case, we click on the chimney, you get the smoke symbol And we can turn the other parts on and off by just clicking on their respective parts. So the Christmas lights, fairy lights on and off, you just click on those and they go off, click them again and they go on. For the interior light, click on the window, and for the snowman, click on the snowman, and that will turn the NeoPixel off and on. It's always nice to see the finished product, especially when you've designed the printed circuit board yourself. I hope you found that interesting. If so, please click like and share the video. I'll be working on more Raspberry Pi projects in future, and I also plan to cover PCB design using the professional free program KiCad. If any of that sounds of interest, then please subscribe to my channel so you get to see the future videos. Thanks for watching.